Good morning, my name is Quentin Haynes. My project is a comprehensive business requirements document for a machine learning quote acceptance prediction feature within an insurance agency's existing quote generation system. The business problem is that insurance agents currently generate quotes but do not have a consistent data-driven method for determining which customers are most likely to accept them. Follow-up decisions may depend on individual judgment, which can create inconsistent practices and inefficient use of agent time. The proposed system addresses this problem by using historical quote and customer outcome data to generate an acceptance likelihood score or a high, medium, or low category after a quote is created. The prediction is displayed only to the agents and is intended to support rather than replace their professional judgment. The primary business requirements are to increase quote conversion, improve agent productivity, reduce inconsistent follow-up practices, create additional value from existing customers and quote data, and preserve accountability. The system should help agents identify customers who may require additional attention while keeping the final follow-up decision with the agent. The enhancement must also fit into the current quote workflow, so employees are not required to use a separate application. The technical requirements are divided into functional and non-functional requirements. Functionally, the system must call the machine learning prediction service after a quote is generated, then return an acceptance score or category, and display the result only to the agents. The agents must also be able to view and sort recent quotes by likelihood category. The system must store the prediction, timestamp, model version, quote identifier, agent identifier, and final quote outcome, so performance and business impact can be evaluated. An important exception handling requirement is that quote generation must continue even when the prediction service is unavailable. In that situation, the agent receives a message indicating that no prediction is currently available. The non-functional requirements focus on system quality. Prediction processing should add no more than 3 seconds to the normal quote workflow. Customer and quote data must be encrypted both in transit and at rest, and only approved data elements may be used. The display must be understandable to agents who do not have statistical or machine learning experience. The system must also support audit logging, model monitoring, version control, retraining, rollback, and documented releases. The project includes several important use cases, such as the customer requests a quote and later accepts, rejects, or allows it to expire, but never sees the prediction. The insurance agent creates the quote, views the internal prediction, sorts quotes by likelihood, and prioritizes the follow-up. The quote system submits approved data to the prediction service and stores the prediction and outcome. The machine learning team develops, validates, monitors, retrains, and versions the model. Compliance and data governance stakeholders review privacy, approved data use, fairness, and regulatory obligations, while management evaluates accuracy, adoption, conversion impact, and overall business value. These use cases can also be expressed as user stories. As an insurance agent, I want to see a quote acceptance prediction after generating a quote so that I can prioritize follow-up more effectively. As a compliance stakeholder, I want the model to use only approved data and retain auditable records so that I can evaluate privacy, fairness, and regulatory compliance. As a member of the machine learning team, I want predictions, outcomes, and model versions to be stored so that I can monitor performance, detect drift, retrain the model, and roll back after an unsuccessful version. My final document contains 4 major diagrams. The sequence diagram on page 12 shows the order of interactions among the customer, agent, quote system, machine learning prediction service, and monitoring components. It also includes the alternate path in which the quote process continues when the prediction service is unavailable. The use case diagram on page 13 shows the responsibilities of each actor and emphasizes that the prediction is internal and not visible to the customer. The UML class diagram on page 14 identifies the primary system entities, including the customer, quote, insurance agent, acceptance prediction, model version, quote outcome, and monitoring record. It also shows how those entities are related. Finally, the data dictionary and data flow diagram on page 16 identify the major data elements and trace how information moves from quote initiation through prediction, storage, outcome, capture, monitoring, and management for compliance reporting. Two important concerns that I identified during the project evaluation were fairness and security. The fairness concern is that historical sales data may contain patterns created by previous differences in customer access or agent behavior. A model trained on those records could reproduce those patterns. The response is to use approved variables, conduct fairness testing, monitor outcomes across all the relevant groups, and maintain human oversight. The second concern is security and system resilience. The project involves sensitive customer information and introduces machine learning risks such as manipulated inputs, compromised training data, or unauthorized access to model assets. Recommended controls could include encryption, role-based access, multi-factor authentication, input validation, audit logging, restricting access, and then incident response procedures. The system is also designed so a prediction service failure will not prevent the agency from actually generating a quote. My hope is that my project demonstrates how predictive analytics can be integrated into an operational insurance process to improve productivity and decision making. Its value depends not only on the model accuracy, but also on usability, security, fairness, auditability, system reliability, and then of course continued human accountability. So thank you, and I hope you enjoy reading my final project, and I look forward to reading all of yours.